Tiger Sensei!
Welcome back, Blue Belts, for another 4 Caillou challenge called a simplistic TCP finite state machine. And so basically we are going to be building a finite state machine, which you should definitely look up at least the concept if you're not familiar with. This is a common pattern in software. And as usual, I'll leave you to read the description, but just note that they give us a bunch of events, a bunch of TCP states, and we'll use that to sort of set up this state machine that will have defined transitions. So based on your current state, if a particular event happens, you transition to a new state, and it will be possible for an event to occur when it shouldn't, and we're responsible for returning a string that says error, I believe. I would say here, yeah, in all caps, error. But yeah, that's it in a nutshell. I think it's straightforward enough. They do even have a link here for designing a state machine, which I didn't look at. They do give information on TCP, which you'd probably be interested in, as it's part of communications for the internet, like something called UDP as well. Good info if you're just curious, which you probably are if you are here. But anyway, let's get into the challenge. As usual, pause the video now if you just want to have a complete from scratch go at it yourself. Otherwise, I'll give you a couple ideas to start with, and you can pause again and sort of implement what I lay out. So, to get into this, I'm just going to kind of type out like a really simple algorithm at a very high level, and then we'll implement it. You can first if you want, or we'll do it together. So the idea here is that I'm going to do something like this. I want to load these events, right? We're passed in this string array. These are the events they told us about in the description. I'm decided to load these into a queue. A queue is a data structure, first in, first out. Whatever event gets in the queue first is the first thing that comes out. So it's kind of like in order processing, just like if you're at the supermarket in line waiting to buy something, you wait your turn. Anyways, then we can say something like, while the queue isn't empty, in other words, while there are items to process, we will say we're going to do something like dequeue an event, which is just pulling the next event out of the queue. Then with that event, right, we're just going to send the event to the FSM for processing, right? We're going to build a state machine. And the idea is that we're going to pull these strings in order out and send them to the state machine. And then the state machine can update its current state and also ensure that no errors happen. So then kind of in pseudo code here, we could say if the event is valid for the current FSM state, update the state and continue. And the idea would be is else return error, right? And then finally, the idea is that at some point you're going to run out of events in the queue, and then it's as simple as just returning the current state of the FSM. Return the current state of FSM as an uppercase string. And that's it. So a lot of times when I'm designing software, before really getting murky into the details, I like to just make a high-level view that's really, you can see this is what I did here isn't anything complicated. It's really simple. Now, implementing it is another thing, but take it in layers. Start very easy at the top and sort of delegate each of these jobs. Imagine there's an agent that loads events into the queue for you, and there's this finite state machine agent, right? And we have a queue that we're working with. So that's a good tip for when you're designing your own systems. Make it easy for yourself. I like to think, wouldn't it be nice if I had this code that did this on my behalf for me? And then I end up coding those things myself. But of course, in a team environment, you could give that job to somebody else. So let's start here. What do we want to do? To start, maybe I will list out the states that we're dealing with, the valid states. So I'm going to make an enum for this. These are enumerations. I'm just going to call mine states. Maybe you want it to be TCP states, or give it a more meaningful name. If we had a larger project with other kinds of state machines, that would be more important. For simplicity here, I'll just call it states. And I'm just pulling these right from the project description. So received, and the numbers aren't meaningful. I'm just putting them in order. It doesn't matter which numbers you assign these as long as they're unique. We just want them to be unique states. Established is 4. They had fin weight 1. I'll call 5 fin. I'm sorry. Closing equals 6. Fin weight 2 equals 7. No, time weight equals 8. Close weight equals 9. And last ACK equals 10. And you can get kind of an idea of how the communications work. I don't need a comma after that last one. But you can see how it's kind of opening a tunnel for communication. There's synchronization signals. They're making sure both sides are connected and receiving data from each other. And then you can close the connection. And yeah, so I won't go too far into that. Okay, good. So we've got these states that will be useful. We'll see that as I go on. Next, I think, how do we want to deal with this? Maybe we'll design the finite state machine. That probably makes sense. And then I'm going to use a factory pattern to sort of offload the heavy lifting of making the finite state machine, because in this method that I'm creating up here, traverse states, my final code is going to look something like this. It's going to be invalid C# code, but I'm going to keep it really simple like this. So next, let's make that finite state machine. How about that? So I'll go down here. I'm going to make a class to this end. I'll call it public. Oops, caps are on. Public class. I'll call it FSM for short, finite state machine. And constructor. And then, so what do I want my FSM to have? I'm going to design this with, I'm going to have a list of finite state machine states, and we'll of course have to define that. I'm making this up, right? Which I'll call states, and I'll just go ahead and initialize this to an empty list for now, just so, to avoid errors when we go to use it. And then I want the state, the current state of the machine to be accessible. That's why I'm making this one public. I made the states private because outside users don't need to know the details of the state machine. But for our challenge, we do want to know the current state at the end, right? Because we have to return what state it ended up in. So I'm going to say FSM state. I'll call it current. Maybe not the best name. And users will be able to obtain this state information, but the setter is private, so they can't modify it. Where only internally does the finite state machine, is it able to modify the state of that. So let's make a couple methods to this end. In terms of building the finite state machine, I'm going to have a public method called addState, which is going to take an FSM state, and then maybe I'm going to add a little flag here, initial state, because if you remember from the description, it said we should start in the closed state. So as I build this thing, I'm just going to flip this flag true when I put in the closing state. The others, I don't need it. In fact, because I don't need it, I'm going to make this a default parameter to false, where I don't even have to pass the information in for the other states. If you're not familiar with default parameters, you probably are at the blue belt level, but that's the magic here. So for the method body, then we want to say basically our collection of states, what we want to add to the list, what we passed in here. And then let's check if that flag came. Initial state then we're just going to say that current is equal to the FSM state. We're just setting that. We have to set that initially, right? So that's the idea here. Simple enough, right? Easy peasy. And then you could probably imagine what the only other thing we really need this class to do is to process events. Remember, we were going to pull events from the queue and send them to this finite state machine so it can update itself. And so let's do that. Public, I'm actually going to make mine return a bool, and I'm using this as a sort of flag for when an error happens. If everything goes right, I'm going to return true, and if we get an invalid event for a current state, I'm going to return false, and that's going to be my flag that, hey, this thing went off the rails, just return that error string. So I'll call the method process event string. I would like to call it event, but remember, event's a keyword in C#, so I'll just put E for now. Okay, and then, so how do we do this? The logic is fairly simple. We're going to check that the current state, remember, well, maybe I should implement to make this make sense, let's implement the finite state machine state class, because that's what current is. Remember, current is an FSM state, which we didn't define yet. So let me go ahead and implement that. I'll say public class FSM state. Oh, I'm sorry, no parentheses after a class name. And then we'll have a constructor here, public FSM state. And it's going to take that state enumeration, the enum we made earlier, as the argument to it. And before I implement the body, we'll go ahead and leave the braces there. What kind of data will this hold? Well, it's going to hold that state information, right? Whatever enum value corresponds to this instance. And again, you can view it, but you can't change it. Outsiders cannot change it. And then I'm going to use a public dictionary of string, which represents an event, to this states enum. Remember, we're going to be bouncing between states. So based on an event, it's going to tell us which new state to update to, and then the state machine is going to go through its list of states, find that, and set the current to whatever the new state should be. So we use this dictionary to sort of map out those transitions. And for these properties, I'll have get and set here. Our factory method's going to sort of build these transitions. We're going to hide away the kind of the ugly details of constructing that. But that's as simple as this FSM state is, right? It represents a state and then how to transition out of that state, the valid ways. So really that's it. So now that we have this simple FSM state definition, it makes a little more sense. We can think about how to process events. Remember, current is one of these FSM states, so we have its methods available to us. So I can say current transitions, right? We're going to check that dictionary. We're going to take the input passed in here, this event, and that's going to be the key in this dictionary. Oh, I forgot to name this transitions. Let's add that. Okay, so if current transitions, and remember the dictionary class has a method called contains key. So we want to make sure it's contained, right? If there are no transitions associated with this event, that's an error, right? So that's when we would fail out. So, but provided there is a transition, everything's kosher, we'll say states next, meaning the next state would be current transitions, passing in the event, the valid event, to the dictionary, and it's going to give us the value, right? You pass in the key, you get the value associated with that. So that would be the enum, the state's enum, representing the next state. Then we can say int index equals the states collection. And we're going to say find index, right? Because we're searching within our collection for this next state. And so since each item in the collection is an I reversed the letters, FSM state, I'll use that as my parameter name for the lambda, and I'll say FSM state dot state. Remember, it has the enum as a publicly accessible property here. I'm checking that it is equal to next, right? The value from the dictionary. And so assuming that states has that it finds that state, then this index should be greater than or equal to 0. So we'll do a check for that. If index is less than 0, that means it wasn't found, right? This should return -1 in the event that it wasn't found. You could write some kind of, we might not even need this, but a lot of times when I'm coding, I might just do this for a sanity check, right? I might do something like this: console write line. I wouldn't really write this in real code, but just want to grab my attention. Should never get here. We shouldn't get here because the dictionary we already found contains a key here. So that would be very unusual. I'll delete this before we submit, but sometimes you want some error checking like this in your code to do yourself some favors while you're building. And then I'm just submitting some data here that could be helpful if that event ever came up, but it shouldn't. So then current is going to be equal to states at that index, right? Provided it's valid. And we're simply returning true here. All the work's done. We've found the next state. We set the next state. We're done here. But if the transitions did not contain that event, then we're simply going to return false. And that's nice. That just tells us, whoever the caller is, that this is wrong, something went wrong, exit, terminate, however you should deal with that. So good. We have process event. We had add states. I think that's all we really needed to implement. So I think the next step then would be to create the finite state machine, right? So let's do that. I'll go down here. Okay. Maybe I'll expand this too, since you don't need to see the description. I'm going to add some new lines just in case, so all my stuff's visible on the screen. So let's create a factory. Let's use the factory pattern to make some finite state machine states and a finite state machine itself. So I'll start with public static class. Let's call it FSM factory. And it's just as one simple job. Just give us an FSM. We don't want to see all the ugly logic. This would be in its own file in a real program. So I'll say public static. Remember, static's turning off object-oriented programming. We're not creating objects here. It's going to return a finite state machine, which we already defined. And I'm just going to call it create. The method is going to be called create. And so for this, I will say to start in FSM, I'll call it FSM in lowercase, equals a new FSM, right? We've defined this. So now we have one. Now we're going to add a bunch of states that represent the instructions from the challenge description. So we can say things like FSM add state. And then I think I hinted that we're going to create an FSM state factory for each of these enumerations. So we had state closed, right? And remember, I added that optional flag. I'm going to set it to true because I want it to start in the closed state. But then, it's a matter of, you can copy paste this thing for each of the other states. And I think I got them all. And then finally, don't forget to return the FSM state machine. But of course, these don't exist yet, so I got to make another factory for that. We use these factories sometimes when object creation is not straightforward. It's involved, and you can kind of hide it all in this, and then it's nice because users can just call, hey, FSM factory create, and it just gives it to you, and you don't have to worry about any of that. But let's go ahead and create our FSM state factory as well. FSM state factory. Maybe you'll appreciate this pattern a little more as I type this out. Public static FSM state, it's returning each time, right? And create. And in this case, we need to know the state that we're creating it for. States state. Remember, our FSM state takes that information in the constructor. So now we're going to do this kind of big if-else thing for each state, but let's do some common logic at the top. I can say FSM state, lowercase, equals a new instance, and I'm going to pass that state to the constructor. And then I'm just going to set up our transitions dictionary, which was string to states. Call it transitions, similar to our class. And we're going to make a new dictionary of string to states. Good. And now the fun, you get to test out your typing abilities. If state equals states closed, now you're basically going to, in this section, we're just going to load up the appropriate transitions, right? So we're going to say transitions equals new dictionary string. And I'm going to copy and paste this. I'll fast forward through this too so it isn't as painful to watch. Let's initialize this. And then I can say app passive open. Remember, I'm just taking this from the challenge description. States listen, comma for another one. App active open, comma. Okay, so we've got these all written out. Be careful as you're doing that so you type them correctly. Then finally, we're setting those transitions to the local variable we created, and now the FSM state is ready to return. It has both the state information populated and the transitions. So yeah, this is a big ugly if-else, with what, 10 or some cases to it, but we would just bury this in another file and we wouldn't have to look at it anymore. So good, we have our factories. What else do we need? I think we're ready to code the method now. I think we've got all of our support, all of our minions in place to each do their job. So let's go back to the top and see how straightforward it is now to implement our pseudocode. So let's have a go at it. So we could say, I'm going to create an instance of the finite state machine, FSM, and now I can do that. Remember, I could have just done all that ugly stuff right in this method, but it would have been so bloated and huge. That's just nasty. We don't want to do that. So FSM factory create. Good. That's simple, right? And then I said I want to use a queue structure. I'll name it queue. New queue of type string. The events are strings. And I can pass in the string array right to the queue constructor to load those up for me. Then this would represent line 2, right? We're getting there. Line 1, load the events into the queue. I should have mentioned something about creating the state machine. But anyway, we can say now, while in order to check if a queue is empty, it has a property called count, and so empty, you could imagine, would be less than or equal to 0. So I'm going to say while it's greater than 0, in other words, while there are events in the queue to process. What's going on with my alignment here? It's ugly. Okay, so while there are events to process, we'll say string next event equals queue dequeue. It has this property, just take the next one out of the queue. Good. And then we're going to say if, remember this was the nice part about our process event method, it returns a Boolean. So now I can check if not FSM process event, next event. And you want it to kind of read like English like this, you know, it's nice when everything kind of flows like that and it's very easy to understand. I'm going to say return error. That was what they told us to do in the challenge. If it doesn't, because I don't have to do anything if process event comes out right. We're just going to keep going through our, just continue back to the top, grab another event, keep going to the end. And then finally, after we've done all of this, we really get to just make this as simple as return FSM current, right? The current FSM state. It had a property called state, but note that this is of type enum right now, but you can use the toString method to get the actual text of it, and that's why I capitalized all these, because they wanted the result in caps. If you didn't, of course, string has a method to capitalize, so you could have called that as well. But I think something like this should do it. I'm going to minimize my screen again. I'll get rid of some of these excessive new lines. And let's do some testing and see what kind of mistakes I made. I already know they're going to ding me. So before I even run, I'm going to say using systems, system collections, generic, because I brought in the Q type. So I needed that. Let's try this. Let's hit a test. Error on line 49 space 32. Let's scroll down and check it out. 49. What's on 49? Public void and state. Oh, sure. I have a type here, but I didn't give a parameter name, did I? So FSM state should have been FSM state. Something like that. Let's hit test. Okay, line 76, typer namespace, FSM states. Yeah, it shouldn't be plural, I don't think. Let's go down. What line was that on? 76. FSM states. Yeah, we called the class state with no plural. Let's get rid of that. Test. Error the type or namespace states. I did it again. 76. Sure, yeah, I copied the same thing in the generic right there. The name FSM factory does not exist. Look at, I can see I lowercase the F in factory in the second word. We need to camel case there. Where was that? FSM factory. That was on line 15 where we called it. Yep, that's fair. What else? The name states does not exist on line 67. Yeah, it was underscore states. I do that with private members. I add the underscore and start them with a lowercase letter. Sheesh, a lot of typing errors. Okay, what's next? I did hit this should never get here kind of thing with the send state. Let me see let's try to figure out what happened here. Okay, I see what happened here. We forgot to assign the state that was passed into the FSM state constructor. That is definitely a problem, so it would default to 0. That's why I thought every state that was being built was in the closed state. So yeah, let's set that. Okay. Good. And green is golden. So go ahead, and if there's any cleanup you want to do before you submit, I can get rid of my pseudocode here. It's just to help with my explanation and give you a framework to start with if this was a little overwhelming. Some serious formatting stuff going on here. Okay. Yeah, I don't think I have anything else to do. But yeah, you can see how simple this is to implement once you kind of get your structure in place, get your little minions made, so to speak. Got the enum. I'm going to get rid of this clause, which I didn't really need, but was helpful. Process event. Let's see, anything else I want to clean up? I don't think so. Yeah, I'll leave it like that. So I'm gonna minimize this. They're gonna make me run it again because I modified code, which is fine. And yeah, I'm gonna go ahead and fire mine off, get those honor points, and go ahead and check out what other people did. Here's a very nice short implementation. See if you can learn from other people as well. As usual, hit me up with questions and comments. You know where to find me. I appreciate the likes and subs. I will see you in another video. Thank you.